electromagnetic field. In electromagnetic fields, we define two potentials. One is vector potential and the other one is scalar potential. Vector potential is denoted by A, while the scalar potential is denoted by phi. In electromagnetism, we write E in terms of vector potential and momentum in terms of vector potential and energy in terms of scalar potential. So, momentum in terms of vector potential can be written as, and energy in terms of scalar potential can be written like this. As we know that energy of the relativistic particle is given by taking square on both sides, the equation will become like this. Now substitute these two values in this and this. So if we substitute E minus E phi whole square, P minus E8 over C whole square, C square, M square, C4. The equation will get the form of, if we rearrange it, taking LCM CP E और C square plus M square C4. अगर हम इस स्क्वायर को खोलें तो हमारे पास ये चीज़ जो है इसके ऊपर स्क्वायर आ जाएगा और इस पर भी स्क्वायर आ जाएगा, तो ये चीज़ और ये चीज़ कैंसिल हो जाएंगे आपस में. E minus E phi whole square plus M square C4. क्वांटम मैकेनिक्स में हम एनर्जी और मोमेंटम का ऑपरेटर पढ़ चुके हैं. एनर्जी का जो ऑपरेटर है हम उसे क्या कहते हैं, E इज इक्वल टू आयोटा एच स्क्वायर पार्शियल ऑफ पार्शियल टी, और मोमेंटम का जो ऑपरेटर है उसमें माइनस आयोटा एच स्क्वायर डेल. अगर हम इसको इस इक्वेशन में सब्स्टिट्यूट करें इक्वेशन नंबर 1 में, तो हमारे पास ये क्या हो जाएगी इक्वेशन, आयोटा एच स्क्वायर पार्शियल ऑफ पार्शियल टी माइनस ई फाई होल स्क्वायर, मोमेंटम C del minus EA whole square plus C square. Okay. This is equation number 3. Multiplying both sides of this equation by a function psi, by wave function psi, partial of partial t minus E phi whole square psi is equal to minus e squared C del minus EA whole square psi plus M square C4 psi. We can see that this is A minus B whole square, and if we take minus sign common from here, this will get the form of A plus B whole square, right? So we can write it as iota h squared partial of partial t minus E phi whole square into psi is equal to minus common ले iota h squared C del minus EA whole square into psi plus M square C4 into psi. Okay. Iota h squared, let me tell you, A minus B whole square is equal to A square minus AB minus BA plus B square, right? We can write it as partial of partial t minus E phi whole square. इसको ना आपने ओपन करना है और बिल्कुल ऐसे ही ओपन करना है जैसे मैंने इसको ओपन किया. तो यहाँ पर ए जो है वो आयोटा एच स्क्वायर पार्शियल और पार्शियल टी है, इसका स्क्वायर minus A, यानी iota h squared partial of partial t e phi, right? Minus BA e phi iota h squared partial of partial t, right? And then plus E square phi minus h squared partial of partial t, partial square of partial t square, minus iota h squared. E is constant, so we can write it here. Partial of partial t phi minus E phi iota h squared partial of partial t plus E square phi square, right? Now multiply both sides of this equation by psi. Iota h squared partial of partial t minus E phi equal to minus h squared partial of partial t psi, right? Partial square of partial t psi. And then next term was minus iota h squared e partial of partial t phi into psi, right? Next term is minus iota h squared e phi partial psi over partial t, and the next term is E square phi square psi, right? Is there any mistake here? Yeah, there is a mistake here. This is h square, right? Answer is h square. Okay. Now by applying product rule here, we will get h square partial square psi over partial t square minus iota h squared e phi partial psi over partial t and minus iota h squared partial e phi partial phi over partial t minus iota h squared e phi partial psi over partial t, right? Plus E square phi square psi. This term and this term, the second term and the fourth term both are same. So it will get the form of partial square psi or partial t square minus iota h squared e phi e psi partial phi over partial t minus 2 iota h squared e phi partial psi over partial t plus E square phi square psi, right? We take psi out of this expression, like then it will be like this, right? Now substitute it. Second expression, we have to expand this also. Iota h squared c del plus e whole square multiplied with the psi already. Iota h squared c del whole square psi. plus 2, 2 A A into B, then third term B into A, fourth is B square A square psi minus H cut C square del square psi. Product rule, apply product rule here, plus iota H cut C E A del phi plus iota H cut C E phi del A. Okay. Now iota H cut E C A del phi. This and this term are same, right? Minus H cut square C square del square phi. This will get the form of 2 iota H cut C E A del phi plus iota H cut C E phi into del A, right? Now substitute this one and this one in equation in this equation number 4. Now substitute the values. Minus H cut square partial t square minus H cut E partial phi over partial t minus E iota H cut E phi partial over partial t plus E square phi square. Here psi is equal to minus H cut C square del square plus 2 iota H cut C E A del and plus iota H cut C E del A plus E square A square into phi plus M square C4 into phi. Now divide both sides of this equation by M square MC square. Here let's suppose sin to R is equal to psi prime R into D E iota M naught C square D over H cut. Now differentiate it first time. It will get the form of iota M naught C square over H cut psi prime R into T E power iota M naught C square T over H cut plus E power iota M naught C square T over H cut into psi dot prime into RT, right? Second derivative, first differentiate this. It will become iota square M naught square C4 over H cut square into psi prime RT E iota M naught C square T over H cut, right? Now iota M naught C square over H cut E power iota M naught C square T over H cut and differentiate it phi dot RT, right? Now differentiate this one. Plus iota M naught C square over H cut E power iota M naught C square T over H cut phi star RT, right? We are differentiating this one. plus, now differentiate this one. So e power iota m naught c square t over h cut double dot prime into rt. We can take this out. This one, this one, this one, this one. Minus m naught c square h cut square these two terms are same, so we can write it like this too, right? Now substituting in the above equation, that was this one. Yep. Here you can see minus h cut square, right? Minus h cut square, then this h cut square will go out. Write it. Minus minus plus m naught c4 psi square rt, right? Now minus plus minus 2 iota m naught c square over only psi. We'll get h cut here because one h cut will cancel out. rt minus h cut square psi double static rt other terms are as it is. Write them as it is. Minus iota why it's not. This is equation number 5. Now divide this whole equation by m naught c square to m naught c square. If we divide this by 2m naught c square, this will give us c square psi r psi 2 minus 2 cancel this iota h cut psi dot prime, and from here minus h cut square over 2m naught c square psi double derivative minus iota h cut e psi prime partial phi or partial t over 2m naught c square minus 2 iota h cut. 2 will be cancelled out, right? Iota h cut e phi partial and partial t psi static over 2, I don't know, c square, and then we have write this term. Now this e square phi square over 2m naught c square phi prime e iota m naught c square t over h cut, right, equal to Right now, write the right hand side. C square will be cancelled out, so h cut square del square over 2m naught. 2 will be cancelled out, c will be cancelled out, so alpha h cut e a del over m naught c, right? This one c will cancel out, alpha h cut e del dot a over 2m naught c, and e square a over m naught c square, 2m naught c square, bracket close, prime e power alpha m naught c square 3 over h squared plus m square. This will get cancelled out, m c square over 2, right? In non-relativistic, this is the Klein Gordon equation in relativistic form. Now, for non-relativistic case, as we know that m naught c square is very greater than e phi. So, neglect the terms which has e m naught c square in the denominator. By applying this condition that m naught c square is very greater than e phi, we will cancel out the terms which has m naught c square in the denominator. First, cancel out this term with this term because these both are same, right? When we multiply this term with this, then these two terms will get similar, and with opposite signs, so they will get cancelled out. This will become 0. This will become 0. This will become 0. This will become 0. This one will also become 0. Okay. We have this one, iota h cut minus iota h cut size dot prime is equal to minus h cut square del square over 2m naught plus iota h cut e a del over m naught c square c, and then iota h cut e del dot a divided by 2m naught c, right? And the next one is these 4 terms, right? 1, 2, 3, and the 4, right? All these terms get neglected. So this is the non-relativistic Klein Gordon equation. Minus iota h cut partial psi prime over partial t is equal to minus h cut square del square over 2m naught, right? Plus iota h cut e a del over m naught c plus iota h cut e over 2m naught c del dot a. ये दो टर्म्स क्यों आई हैं? क्योंकि हम ये इलेक्ट्रोमैग्नेटिक फील्ड में हमने चार्ज पार्टिकल को रखा हुआ है, इस वजह से। अगर ये चार्ज पार्टिकल हम इलेक्ट्रोमैग्नेटिक फील्ड में ना रखते तो ये टर्म्स भी ना आती, फिर हमारे पास जस्ट काइनेटिक एनर्जी और पोटेंशियल एनर्जी आती। सो दिस इज द क्लेन जॉर्डन इक्वेशन फॉर non-relativistic particle. Thanks for watching this video. If you like this video, please hit the like button and subscribe this channel.